Ginsai.com. Ginsai.com.
Okay, welcome to a lesson on JavaScript variables. I've recently sort of changed my attitude about how I teach JavaScript. JavaScript is a very free-form language. It lets you get away with a lot of stuff. A lot of stuff that you have to do in other computer languages you don't have to do in JavaScript. But then I was writing a game in JavaScript one day, and I was planning on also writing the same game in Java. Now, for those of you that don't know, Java and JavaScript are two very different languages. But I was planning to write the same game in both languages. And I realized when I was coding in JavaScript, if I did it in a certain way, it would be easy to recode it in Java. And then I realized on top of that, JavaScript is very much a beginner's programming language. Often students go on and learn other languages like Java, C#, PHP, and I realized I really need to teach JavaScript in a way that makes it easy for you to learn other languages beyond JavaScript. So I've completely rethought about how I code in JavaScript and how I want to teach students how to code in JavaScript. I realize there's a core of language elements that is common to every language: JavaScript, Java, PHP, C#, C++. And what I really want to teach is that core. And even when I'm teaching JavaScript, I want to teach it with an eye towards you learning other programming languages. So here we go. Here's my new way of teaching JavaScript. I hope you enjoy it. Let's start with JavaScript variables. According to dictionary.com, a variable is likely to change or vary, subject to variation or changeable. My definition, or the way I've thought of variables, is it's a location in computer memory where I can store something. It's a cubbyhole where I can put something and use it later. I like to think of variables as a location in memory where I can store things. But keep in mind, it's subject to change. It will vary. That's why they're called variables. They change as the program executes. Let's get started here. Now, the first thing I've sort of changed about the way of teaching is, see that keyword var that we put in front of a variable declaration? This is a variable declaration in JavaScript. That is completely optional. You can put var there or you can't put var there. It's not a requirement to put var in front of it. But other languages like Java, C#, C++ require you to declare the variables. You'll usually put something like int or float or double in front of it. So I decided from now on, when I'm teaching JavaScript, I'm going to insist that I always teach you to put the keyword var when you're declaring a variable. What you're saying here is I want to allocate some space for a variable called x position. I'm going to store the x coordinate of my player in the game in this x position variable. Now in JavaScript, when you declare the variable like this, it allocates the space in computer memory, but see the question marks in that space that I allocated? That means the value is undefined. I couldn't use this variable in a math equation, for instance, because it currently has no value. Now let's allocate or declare a variable called y position. And again, I want to insist that when you're declaring a new variable, when you're creating a new variable, you put the keyword var in front of it. But this time, instead of leaving the value undefined, I'm going to set y position equal to 50. Now you'll see not only does it allocate the space for y position, but it assigns the value 50, and I'm good to use y position in the code any way I want. These are called integer variables, and in other languages you would use the keyword int instead of var in front of it. In JavaScript, we don't have to declare the exact type of the variable, but I do want you to use the keyword var to declare a variable and say I intend to allocate space for this variable. An integer number is a number without a decimal point, and I plan to store numbers without decimal points in the variable y position. Next up, I'm going to declare a var money equals 20.0. Money is going to be the player's money. As the game progresses and they collect money and they spend money, this value should go up and down. That's why it's called a variable. The value of money goes up and down. This time I'm going to assign it a value of 20.0, which means I want a floating point number. A floating point number is a number with a decimal point. I've got a secret for you. Technically, JavaScript stores all numbers as floating point numbers. Although when we assign a number without a decimal point, JavaScript won't display it. Under the covers, all numbers are floating point numbers. Next up is a var rank equals A. This looks a bit like a character variable. In other languages, like Java or C#, they have a char data type where you can allocate one character. Again, under the covers, JavaScript's a little bit different. JavaScript stores these as strings, so this is technically a string variable with just one character in it. This will be the player rank. A, I assume, is a high-ranking player. A D is a low-ranking player. JavaScript does support the Boolean data type. You can see I'm var paid user equals true. I'm going to assign the Boolean value with the keyword true in JavaScript. I'm going to assign that to the paid user, and I can only assign two values to a Boolean variable, true or false. And in this case, I'm assuming paid user equals true means the user has paid to play the game. Perhaps they'll get access to more levels because they're paid user. Perhaps they'll get more goodies or more. Now, the picture I'm trying to paint here is whenever you create a variable in JavaScript, it allocates some space in your RAM memory. And that space should be assigned values so you could then use that space. In the first example, when I didn't assign a value, you get an undefined value. I tend to lean towards just always assigning a value at the beginning. Even if I don't intend to use that value later, I plan to change it before I use the variable, I tend to assign an initial value when I do it. One of the things the initial value does is it gives you a good idea what you intend to store in it. I can see in Y position I intend to store an integer number, a number without a decimal point. I can see I intend to store floating point numbers and money. I can see I intend to assign characters to rank, and I see I can assign, I'm going to assign Boolean values, true or false, to paid user. I like to initialize my variables when I start. Also notice I put a semicolon at the end of all of these variable declarations. Again, that is not a requirement in JavaScript. I don't have to put a semicolon after every declaration like this. However, most other computer languages require you put semicolons. So what I want new students to do is get in the habit of putting semicolons at the end of every line. Though you may look at some JavaScript and it doesn't have semicolons at the end, they are completely optional. You do want to start to get into the habit of using it. Again, let's assume that JavaScript won't be the last computer language you learn. And if you learn it in a certain way, the way other languages work, your transition to a new computer language will be easy. If you get into the habit of doing a bunch of stuff that only JavaScript does, like no requirements to declare the variable with the var keyword, or no requirements to put semicolons, if you get into that habit, you're going to have a much harder time transitioning to a new computer language. Let's always use the keyword var when declaring our variables, and let's put semicolons at the end of each line. Now, when it comes to JavaScript's variables, or any variables in any language, there's three critical things you have to understand: the name, the type, and the value of the variable. All variables have a name. Descriptive names are good. Short abbreviations are bad, right? So a variable name like score is pretty obvious. It's the player's score. A variable name like health is pretty obvious. It's the player's health value. If you use variable names like S for score and H for health, it's very difficult to understand as the game progresses what you're storing in that variable H. So use good descriptive names. The name of the variable should always match what you're storing in the variable. If it's the player's strength value, call it strength. Don't call it ST. Variables also have a type. What are you storing? Are you storing a whole number without a decimal point? Are you storing a decimal number with a floating point? Are you storing letters or a single letter? Are you storing true or false? What are you storing in the variable? Other computer languages make you declare up front, I'm going to store an int, or I'm going to store a float, or I'm going to store a char. JavaScript does not require you to declare the type of the variable, but in order for you to get used to doing that, I want you, when you create a variable, to always put the keyword var in front of it. That'll get you into the habit of sort of seeing, oh, this is where I'm declaring the variable. And when you move on to another language, you'll be ready for it. Finally, variables have a value. What is the current contents of the space allocated? JavaScript in all computer languages will allocate space to hold something, and the current value stored in that space is very important to understanding the variable. So make sure when you're looking at a variable, when you're looking at your code and you're trying to figure out what's going on, always remind yourself, what is the name, what is the type, and what is the value being stored in this variable. Let's look at some examples here. I'm going to declare a var score equals 0. Well, the name's pretty easy. It's score. I assume the player is going to be accumulating scores or points while it goes. Score or points, whatever you want to call this. I choose score, is the points that the user is earning as they play the game. When they pick up something valuable, they may get score points. When they vanquish an enemy, they may get some more score points. So score is the accumulated total of the player as they play the game. It's going to be an integer number. That's why I like to put that equals 0 to initialize it, to kind of remind myself that I'm storing a number without a decimal point in this variable. It will allocate the space and set it equal to 0. This will be a completely defined value because I did that equals 0. The player's health. I'm assuming 100 is going to be full health for the player. You should start the game at 100. That's why I initialize this variable at 100. 100 being full health. I assume when the player's health value gets to 0, a player might die at that point. So we obviously do this in video games quite often, where a health score determines whether the player has good health, poor health, or dead when their health reaches 0. And that's sort of the range I want to keep in. When the health goes to 0, the player has lost the game. Now the above two were integer variables, numbers without decimal points. And let's have a player strength variable. How much can they lift? How much can they carry? This might be affected by other factors in the game. So we'll use a floating point number in this so we can have a much greater resolution. We can go up by smaller increments, go down by smaller increments. How much strength, how much muscle mass does this player currently have? We'll initialize it with a value of 4.67. This will be a floating point number where I intend to use the places after the decimal point. Notice how when I'm declaring the variable, I assign an initial value. Now these may be the initial values I want, or it may just be a placeholder so I can see what type of variable I'm trying to store. In this case, strength is the name of the variable. The type will be floating point or double, and the value is 4.67. Let's create a fourth variable here. Screen name equals Hank. This is a new type of variable. This is a string variable. Obviously, the name of the variable is screen name. It couldn't be any more literal than that. Screen name is the player's handle, or what the player wants to be called during the game. Quite often, players will enter their name at the start of the game, and the game will address them by the given name, or the name they desire to be called. In this case, we're going to give it a default value of Hank. I just made that up out of thin air. But again, looking at this variable, I can tell three things. The name of the variable is screen name. The type is going to be a string. I'm going to store letters in this variable. And the initial value, or the current value, is going to be Hank. When you're looking at variables in your JavaScript, focus on three things. Focus on the name of the variable, the type of the variable, and the value of the variable. Again, JavaScript is very liberal on how it deals with variables. Turns out you can assign any type you want to a variable at any point in the game. That's a poor programming practice. Even though JavaScript allows you to change the type of variable while you're executing the program, I'd prefer if you kept the type of the variable consistent throughout the program. So if you start assigning it integers, only assign it integers. If you initialize a variable as a floating point, keep floating point values in it. Try not to switch back and forth between variable types. Again, JavaScript is very liberal, but at one point, if you're going to learn a new programming language like Java or C#, they're not going to let you get away with changing the type of the variable during the execution. So let's declare the variables, let's give them some initial values, and let's try to maintain some consistency in the types that we store in our variables. Once a string, always a string. Try not to change it to a number once it's a string. Changing variables. Let's see how we can change variables while the program is executing. I'm going to declare a var x_position equals 60. Remember, x_position is the position on the x-axis of my character. I'm going to give it an initial value of 60, and what I've done is I've drawn the character here. I've drawn the character at position 60 on the x-axis. Now, variables change. Variables vary. That's why they're called variables. So let's look at some of the changes we might make to this variable. Let's say x_position equals x_position plus 2. Now I've drawn the arrow in this direction to say that this command is going to pull the current value of the x_position 60 out of the variable, add 2 to it, and do what with it? The result 62 will be restored back into the variable x_position. See this x_position equals? This actually executes after the addition. We do the plus 2 first, and then we do the assignment. This is called the assignment operator. Now, when I change the value to 62, I don't know if you noticed, my character here changed a little bit. The position of the character is always going to go off of this variable. If x_position changes, the position of my character changes. So let's change it again. Let's pull the value out of x_position, 62, add 5 to it to get to 67. After we calculate the 67, what are we going to do? Also watch the character. We're going to assign that 67 to the x_position variable. And when the x_position variable changes to 67, I don't know if you noticed it, but this character moved over 5 spaces or 5 pixels. And that's how a character moves. We alter its x_position variable, we alter its y_position variable, and every time through the game, we redraw at that new position. As long as the x_position variable keeps changing, the character will keep changing its position on the screen. I just gave you a lecture about good variable names. We want variable names to have descriptive names like x_position, y_position. I'll be honest with you, a lot of game engines shorten this variable names to x and y. I just didn't want to start the game with very, very short variable names like x and y. Even though it's very clear what x and y is in a video game, I prefer starting you with calling this x_position and y_position. But when you get into real game programming, don't be surprised if they use the shorter variable names, x and y. Up here, I used what's called literal or hard-coded values to change the position of my characters. Not a great programming practice. I started you that way because it's a little clearer how it's changing the variables. Now I want to improve on how I change the character's x_position. So what I'm going to do is set up another variable here. Var speed equals 3. Var means I'm declaring this variable. I'm creating it for the first time. It's going to have a descriptive name called speed. It's going to control the speed in which my character moves. And it's going to have that initial value of 3. And you can see the 3 showed up in the variable space here. Now speed is going to control how fast my character moves. The bigger the speed number, the faster the character moves. The smaller the speed number, the slower the character moves. That's much better than hard-coded values. So this time I'm going to say x_position plus speed. I'm going to pull the 67 out of x_position. I'm going to pull the 3 out of speed. 67 plus 3 is 70. Once I've finished calculating 70, then I will do the assignment operator. And the assignment operator changed x_position to 70. And in case you didn't notice it, my character moved over to position 70 on the x-axis. Another neat thing you can do with the speed variable is alter the direction that the player moves. Not only will it control whether the player moves slow or fast, I'm going to put a negative value now into the speed variable. As a -6, it means I want to subtract from the x_position variable, and I'll move left instead of right. When x_position gets larger, I move to the right. When x_position gets smaller, the character will move to the left. So I can alter not only the speed of the character, but the direction of the character by putting a negative value in the speed variable. Once again, I'll pull the 70 out of X position. I'll pull the -6 out of speed. 70 plus -6 is 64. What I want you to do is look at the character now. Watch the character as I advance this code. Bang, the character just moved to the left. I assigned a new value to X position 64, and the character moved over to position 64. There's great advantages to using variables to control the movement of the character versus hard code values. This is poor programming practice, +2 +5. This is good programming practice, plus speed. And notice the name of the variable. It's controlling the rate in which the player moves too. That's why we call it speed. Good descriptive variable names make your code easy to read, easy to maintain, easy to fix. Short cryptic variable names like SP make your code very hard to read, very hard to maintain, and very hard to fix. So use good, solid variable names. One thing JavaScript is missing is the ability to create what we call a constant or a final variable. Most other programming languages have a very straightforward way of saying, I want this variable value to be frozen, to never change. JavaScript is talking about adding a const keyword so we can do this. And what I'm trying to get to is this idea. I'm going to declare a var start x equals 10, and I never want 10 to change. I want 10 to be the same for the entire execution of this program. Other languages have this keyword const, and JavaScript is talking about adding it. That's C, C++, C# has this const keyword. Java uses the keyword final to say, I don't want this to be the final value stored in it. There are ways in JavaScript that make a variable a constant. You have to know a little bit more about JavaScript and objects to use them. So we're not going to look at them now. What we will do now is I'm going to make my variable in all uppercase. This is a convention among lots of programming languages that says if my variable is in uppercase, I intend for this value to never change. So I'm going to keep it 10 in this start x variable at all time. And what this is going to be is our starting x position. Remember how I said I'm not too thrilled with these hard-coded 60s and 2s and 5s here? I'd rather start at start x every time, and that way if I redo my program and rewrite it, I can always start at the same position. So start x is going to be my starting x position. Let's say my player dies and I want to reset its position. Its default starting position will be 10. Did you see the character just jump? I just changed x position to 10 and my character moved over to position 10 on the screen. The value stored in variables will reflect what's going on the screen. I've been using variables that portend to changes on the screen. X and Y position and speed will alter the speed that the character moves. Variables like score and health will be critical values that we display on the screen as the thing progresses. Think of everything going on in your video game as being reflected by values stored in variables. Floating point and char data type, and we don't really have a char data type, so we'll explain how JavaScript handles that. But we do have a floating point type, and in fact, to be honest with you, all numeric JavaScript variables are stored as floating point values. Even if you don't assign a value with a decimal point, it is technically still a floating point. However, if you don't assign a value without a decimal point, it won't print the decimal point when you look at the variable or you look at the value of the variable. So let's declare a var money equals 50.49. Let's say the player starts with $50.49 in their pocket or purse. Again, I like assigning an initial value so I can tell, oh, I'm storing floating points in his. Keyword var is not required, but when I use a variable for the first time, when I declare the variable, I'm going to urge you to always use the keyword var when you're creating a variable. Not a requirement, but other languages do require a declaration of a variable, and we might as well get you into the habit of declaring variables properly. So var money equals 50.49. You can see I've allocated the space over here in RAM memory, and it has an initial value of 54.9. This is going to track the money my player acquires when they pick up gold, for instance, or they lose money when they buy things. Money comes out of their money variable. On the screen, if I'm showing the player how much cash they've accumulated, the value in this variable will always be reflected on the screen to the amount of money we show the player that they currently have. Now let's say the player buys something. They're going to buy something for $12.34. So I'm going to pull the current value of money out of memory, subtract 1234 to get an answer. And what am I going to do with that answer? I'm going to assign it back into the variable money. The answer was 38.15. That is the current value in the player's purse. It gets reflected on the screen. We do this a lot. When you're programming with game engines, they'll set up variables, and if you put a certain value in that variable, the game engine will reflect automatically what it is. Now, we're not quite ready to show you how to update the screen. We'll get to that soon. So just let's assume the game engine will reflect the current value in the money variable on the screen for us. Again, I'm not too crazy about that hard-coded 12.34. Different items that you buy will have different costs. So what I'm going to do is declare another variable. See that var? That means I'm declaring a variable. The name of that variable is cost. The type is obviously floating point. And the current value, our default value, is $7.11. So I'll put that into the variable and use it on the next line. I'll pull 38.15 out of the variable money. I'll subtract cost, $7.11. I'll calculate the new value that I have because I just purchased something for $7.11, and I will assign the result back into the money variable. So there's my 3104. So I started with 5049. I subtracted 1234. I subtracted 711, and now I'm at 3104. And you can see that the screen now reflects that new value in my money variable. Now let's have a game where we rank the players. So an A player is super high ranking, a B player is a little below that, a C is an average player, and D and F ranked players are newbies, beginners, people who aren't very good at the game. So we're going to set a rank. The first thing I want to explain about JavaScript when I declare this var rank equals C is JavaScript stores these as strings. I know it only looks like one char, and I know many other programming languages have a char data type where you can store a single character in it, but this is technically a string in JavaScript. JavaScript does not have a character data type, it has a string data type. So think of this as a string of characters that just happens to have one letter. Now it's going to get a little more complicated here. Remember I said it was a string? What I'm going to do is I want to change the character ranking. I want it to make it go up. I want it to go from B to C. So it might not be clear here, but look closely here. Rank.charCodeAdd. What I'm going to do is temporarily convert that letter C over to a number. I'm going to get the character code. It's called the ASCII character code of the character at position 0. Well, the first character is always at position 0. So what I'm going to do here is I'm going to convert C to a number, and then I'm going to subtract 1 from C. Well, when you subtract 1 from C, what do you get? Technically, you get B. B is one less character than C. So what this is going to do is temporarily convert our character variable over to a number so I can do a little math on it. Rank has changed to 66. Oof. It seems like the character code for C was 67. I subtracted 1. I got the value of 66. Ooh. I wanted to do some math on this character, so I had to temporarily convert it to a number. Right now it's at 66. Now what I'm going to do is change it back to a character. So I'm going to use this command string.fromCharCode and pass it rank. Rank contained is 66. This converts it back to the character B, or the string containing just the character B, and stores the result back into the rank variable. Notice how I changed this back to a B. Now, It's a string again. Now this again is something we want to kind of discourage here. I had to change it over to an int. I probably could have used another variable to do it and made that an int and kept rank a string. But in this case, since it is basically the same value, I went ahead and used just the rank variable. One of the reasons I'm showing it you this way is you got to be careful. You got to be careful of keeping in mind what is the current type of the variable. Once you start assigning floating points to a variable, keep them floating points. Once you start assigning strings to a variable, keep them strings. I only did this to show you that it can be changed, and not that I want you to be changing between int and string in the same variable. Use two separate variables. If you want to store ints in one variable, store them in that variable. You want to store strings in another variable, store them in a separate variable. And you can see the screen is now updated. I have 31.04 in the money variable. I have a B in the rank variable. That's ranking or showing the people on the screen what their current values are. Let's do some math in JavaScript and see how it works. Another common task in a video game is to track how long it takes for a player to complete a level of the game. So let's track the elapsed time for a game level and see how it's done. What you might not know is this is usually done in seconds, whole seconds. So I've declared some variables up here, var minutes, seconds, and then a time variable. What time is going to be is the total seconds. So when I say time equals 125, I am going to store the value 125. What that's telling me is it's currently taking me 125 seconds on this particular level. Well, players don't want to see the number of seconds. They want to see minutes and seconds on the screen. So what we're going to do is a little math to convert the total number of seconds over to minutes and seconds. I'm going to take the time variable and divide it by 60. If it's taking me a total of 125 seconds, when I divide that by 60, I am going to get the number of minutes it took to do this level. Warned you before, all JavaScript numeric variables are floating points. So when I do time divided by 60, I'm going to get a floating point number. See this 60 divided into 125, right? It goes into 125 twice, but there's something left over. There's a remainder. Now, normally what I would get in the minutes variable is a decimal point. I'd get 2 point something value in it. Now, I don't want a decimal point. I want to show them whole minutes. So I'm going to use the math.floor command, which basically says round the number. Round the number. If it's 2 point some value, round it down to 2 in this case. Minutes equals math.floor time divided by 60 ensures or makes sure the result of my division comes out to be the whole number 2 that I want. And you can see when I set minutes equals, it'll be set to 2. Not 2.1, not 2.2, but a solid whole number 2. That's what I want to show to the player on the screen, that they've taken 2 minutes so far. But they haven't taken exactly 2 minutes. They've taken 2 minutes and change. Remember our division showed us that it's taken us 2 minutes plus an extra 5 seconds. Whenever you do division, you technically get 2 results. How many times it divides, 2, and what's left over after the fact, 5. Now the remainder usually means we need a decimal point. We don't want to show a decimal point. So I'm going to use what's called the modulus operator. That's the percent sign there. What that does, it says after dividing these two numbers, show me what the remainder is. I don't want how many times it divides. I want how much is the remainder. So what the modulus operator does is it does the division and returns directly the remainder after the division. And when it turns the remainder after the division, the seconds is 5. The modulus operator will return the integer remainder after doing the division. Go back again and look at this equation. It's taken me a total of 125 seconds on this level so far. So 60 divided by 125 means it's taken me 2 minutes and 5 seconds. And that's what the user wants to see. They don't want to see 125 seconds. They don't want to see 2.22345 minutes. They want to see 2 minutes and 5 seconds. So I'm showing you how math is done, and all the standard math operators apply. Add, subtract, multiply, divide. This new one, modulus, is the remainder operator. Get used to it. Standard math applies to Java. The big thing you got to worry about, and the reason I explained it this way, is am I storing an integer number or am I storing a floating point number? I'd like you to try to keep integer numbers as strict integers. That's why I did the math.floor, and floating point numbers as strict floating point numbers. Again, that is not a Java requirement. You can take the same number and flip it back and forth between integers and floats, but other languages don't support that feature. So we might as well start programming like we're programming in another language. Did I say that right? So we might as well stick to habits that will be consistent with other programming languages. Try not to mix your floats and doubles in the same variable. Just to make this a little clearer, I did a very, very simple hard-coded example so you can see how math.floor works. 1 divided by 2 in JavaScript is 0.5. 1 divided by 2 will always produce a fractional result, or 0.5. Why doesn't it store 0.5 in the test variable? Well, math.floor says round that 0.5. And when it rounds that 0.5, it rounds it to the whole number 0. In order to prevent a decimal point as a result of this division, the math.floor makes sure it's rounded to 0. And you can see this line of code puts a 0 in the variable test. It's a whole number without a decimal point. What if I leave off the math.floor? What would I get? 1 divided by 2 will produce a floating point number, 0.5. And if I do nothing with that 0.5 and assign it directly to the test2 variable, there it is. The moral of the story is you got to be careful with your numeric variables. If you want to store integers, watch out for divisions. Make sure you take the floor after doing the divisions. If you're looking for floating point numbers, then go ahead and divide them directly. Don't worry about the math.floor. Next up, the string data type. Strings are not objects, but they are similar. In JavaScript, the string is a data type. Just like we have number types and we have Boolean types, we have a string data type. So I'm going to declare a var name variable here. When I declare var name and not give it an initial value, notice how I put the word undefined in the variable. I've said this before, you have to be careful. When you declare your variables with just the var name and the semicolon, it does not assign initial value to that variable. So it technically is an undefined value in there. If I tried to print this, it would be undefined. It wouldn't have a value. So let's give it a value. Name equals Mario. So I'm going to store the character string Mario in the name variable. Again, strings are types. I'm just going to store this value in there. Remember the 3 things about a variable that you have to know. Variables have a name. Well, this one's pretty clear. It's called name. Variables have a type. In this case, it's going to be a string. And variables have a value. This variable now has a value of Mario. Alter this string variable. Whoa, what am I doing there? Isn't the plus sign for numbers and numeric addition? Yes, it is. When the variables are numbers, it will do numeric addition. But when the variable is of type string, like the name variable is, what the plus operator does is string concatenation. It says take this string and make a bigger string by adding this to it. Also notice that I'm using single quotes on brothers. JavaScript will accept double quotes or single quotes when you want to access a string. Both Mario and brothers are both string types. What I'm going to do is extract the value Mario from the variable name and add to it or append to it the word brothers. And what you'll see, Mario Brothers comes out. That's what the plus sign does when it's between strings. Plus sign between numbers does numeric addition. Plus sign between strings does string concatenation. It puts two strings together and makes a bigger string. What if you mix the two? Name is very much a string variable. So I'm going to pull Mario Brothers out of the name variable. Then I'm going to add a number to it. What did I just say? When you add numbers, it does numeric addition. But I'm not adding numbers here. I'm adding a string and a number. Well, in this case, the tie goes to the string. What it's going to do is make a bigger, longer string. It's going to do string concatenation. In order for it to do numeric addition, both operands have to be numbers. In this case, since the first operand is a string, Mario Brothers, and the second operand is a 2, it's going to do concatenation. It's going to add the 2 onto the string Mario Brothers, and you'll get the value Mario Brothers 2. Got that? Plus sign works differently depending on the context. Put it between two numbers and you'll do numeric addition. Put it between two strings, you'll do string concatenation. Mix the two and you'll do string concatenation. Up here I warned you that strings are types, they're not objects. If you've programmed in Java or C# or another programming language, you'll know that strings are objects in those languages. Technically, in the truest sense, a string is not an object in JavaScript. It is a type. But they behave remarkably similar to objects. So those of you that have programmed in before might think this looks like an object, and I'll be honest with you, it looks like an object to me too. But technically it's not. What I'm going to do is go to the name variable, and I'm going to access what's called the length property. So I'm basically going to ask the name variable, how many characters do you have? Count the number of characters. M-A-R-I, that's characters. How many characters are in this string? And what the length property does for a string variable is return how many characters. And if you go up here and count, Mario Brothers has a total of 14 characters in it. So the length property told me Mario Brother has a 14 in it, and I assigned it to the variable len. That tells me how many characters were stored in Mario Brothers 2. Notice how I use the var because I'm declaring a new variable here called len. I kind of prefer you declare your variables all at the top, but JavaScript, like other languages, lets you declare variables anywhere in the code you want. So I'm declaring a variable len here. The var is what's telling me I'm declaring a new variable here. Let's get in the habit of always using the var when we're declaring a variable. So that's one way to use a string variable. Doesn't quite work with numbers, but when you're using with strings, there's a length property. Ask the string how many characters it's storing. Now this really looks like an object to me. I'm going to go to the name variable and run a function. I'm going to run to uppercase. I'm going to ask the name variable to convert all its characters to uppercase characters. Every character is going to be uppercase, not just the M and the B in Mario Brothers. Boy, that looks like I'm using an object, but they tell me Java strings aren't objects. Now, there are ways to make Java strings objects that we'll look at later, but for now, strings are data types. Special data types that have properties and functions we can run. This function is going to convert our string to uppercase and store the result back into the name variable. So you can see right here, Mario Brothers 2 got changed to all uppercase letters. That's it for variables. Remember, variables could be numbers, variables could be strings, variables can be booleans. We don't have to declare variables using the var keyword, but I would prefer if you declared variables with the var keyword. We don't have to put a semicolon at the end of each line of code, but I'd prefer if you put a semicolon. By using the keyword var and by using those semicolons at the end of each line of code, you're getting yourself in the habit, you're getting yourself used to programming in other languages, other languages that require variable declarations and require semicolons at the end of each line. So let's get into good habits now, and when it comes time to learning a new programming language, it'll be a lot easier. GameSci.com. GameSci.com.